Hello, hello. So, welcome to day 3 of our workshop, where we're going to hopefully finish this whole thing. Our Nurbs geometry is kinda done, almost done. There are going to be a few details here and there that I'm going to add, but the main focus is going to be on the SubD geometry, this one right here. And right at the start of this video, I played a short clip of, I think it was 15 minutes sped up, of me just creating the additional SubD landscape surrounding what we've done in part 2. And I just want to talk about it just for a second. So at this point, you should probably kind of get it of how it's done, right? Let me just unlock this and just hide it for a bit. I want to note that I have created this landscape, like these two additional landscape pieces. I have created them on a flat, on the 0, ground plane, right? So it's completely flat. It's just so much easier to draw them this way, and then to project them, show selected, to project them onto the landscape. And where is my landscape? Oh no. Where did I put it? That's fine. If I think I have accidentally deleted my landscape. Whoopsie. But that's fine. I can easily bring it back with Grasshopper. So that's what I'm probably gonna do. Just a second. Yeah, probably let's do that. So I'll show, I will type in Grasshopper. This is also going to show it for you if you accidentally delete your landscape geometry, of how you can rebuild it. The script was done in part 1 of our workshop. So workshop day 1, that's where it is. And if you haven't deleted the input curves, everything should be neat and dandy. Surface from points, that's the one. Great, there's our landscape. And here I can even now make it smaller, right? To make it focus more on this particular area, right? Because we're using too much of it. But honestly, just to keep consistency and also to get a broader range in terms of the landscape, I will keep its original proportion. So we just choose this, we choose to bake it, and we just bake it into, let's say, default layer, or my landscape layer for that matter. There we go. Then we can hide this, close Grasshopper, and we have our little surface here yet again. Show selected. Let's just show our Nurbs geometry, our SubD geometry. Yeah, it's still following everything quite nicely. And then I just need to project these onto here, right? So we're back to normal. Before I do that, as I am looking at this whole thing, I do notice quite a few, weird areas here and there. So for instance, here the line is going until here, while it's being like, this polygon is too big, right? It needs to end here. So I can just say this point, move from here to here, Control Shift click this point, move from here to here. The topology here will not match up. That is fine. We will fix that. It's fine if it's not matching up. One thing that I can't change here is the geometry that's already projected, because I don't want to mess with the topology of that. So this stays static. I even locked it, right? So it's gray because it's locked. So only these can be changed. Now, as I look at this whole geometry, the blue geometry, I can see that there is one issue that is right here, a naked edge, right here. Something's fishy. Let's zoom in. I zoom into it with zoom selected, and here I can see that these two guys are not matching up, right? So I just click, select both of them, and type in stitch. That's it. I just stitched them together. Now everything is, everything is working nicely. Don't mind the roundiness of it. We will fix the roundiness later. Also, the roundiness is not that bad. It's kind of nice. Either way. Now, as we have these, to project them, we will repeat the same command that we used before. We will filter only by vertices. First of all, let's just check. If you select everything, you only want to be able to select 2 SubDs. Well, in my case, it's 2 SubDs. In your case, it might be more or less, but only SubD geometry. So everything else is locked in this case. And then I will choose selection filter vertices. There we go. It's right here. Select all of these bad boys like that. Project. Enter. Delete input no. Direction Seaplane Z. Just select the surface. Oh yeah. And you won't be able to select the surface because you still have the selection filter turned on. So you need to turn it off right here. You turn off the selection filter, then you're able to select the surface, hit enter, gets projected. There we go. We have ourselves a SubD geometry that's projected on top of our built surface, which now I can hide. Great. So that's what we have. Now we can join it. Well, not really. We still have a few things to do before we're gonna be able to join it. For instance, here, this area right here will require one more line or edge loop going through here. So I can just select these edges, type in insert edge, and just insert it to there. And also then this polygon will require one more edge loop like that. Okay, great. So now this is a grid. This works nicely. And I'm just going to go through all of these to check if I didn't make any, very clear mistakes. Yeah, that seems like it's, that does seem like it's a problem. Right, so I don't really need this edge loop, so I'm just going to select these 3 edges and just hit delete. So now this is cleaned up. And then we continue. Yeah, okay, and then the final one is here, right? This sticking out portion of it. So you can either, if you want it to really stick out, then you can have it stick out, but I don't feel like that's gonna be, and it's not gonna be nice. So I'm just going to create a line, like a guideline, like so. And I'm just going to move each point onto the edge intersection with the line, and it doesn't catch the intersection with the line. Great. So instead I'm gonna move it to the nearest point snap. Sure. We don't need, at this stage, we don't need to be hyper accurate about our topology, so we can kind of get away with these kind of crimes. Just things barely matching up. Either way, now it's done. Now we can just select all of this and type in join to join it all up. After I've joined it, let me change this back to SubD day 2. Sure. Let's change this back to our regular layer and let's just investigate what the hell happened here and why is this edge black. So as I hover over this corner, it tells me there's 2 SubD vertices rather than 1, right? So I can just stitch them together into one, and then immediately it fixes the corner, so I don't need to do anything more. Awesome. Easy. Okay, so that's that. I'm not sure if we want this kind of a dimple sticking out from there. Maybe we do. Sure, why not? Let's just have it there. But yeah, that's our landscape. Right? Created. Now, the next step is to close off the geometry, right? So up until now, all of these openings were, well, openings. They were holes. I need them to be closed off for my next steps that I'm gonna do. So how the hell do we close it off? That is going to be a little bit of a challenge because we have so many such a different count of polygons on each side. Here we have 4, here we have 3, here we have only 1. Holy crap. Here we have also 4. Wait, is that 4? No, that's 3. That is 4. Okay, so it's gonna be a little bit of a challenge, to say the least, right? So the first thing that I'm immediately thinking about is it possible to make out of this part? So what we want is to have 3 polygons on this side, and 3 polygons on this side, 4 on the bottom and 4 on the top. So they need to match up for every single one of these, right? So I'll need to change the topology of this area just a tiny bit for it to work. And I'm thinking of doing it with what if here, this little point right here, we just stitch that to a single point, so that we only need to deal with 2 polygons. And here here we just would need to create a triangle, right? So we delete that. We create a 3D face, which would be a triangle going to the midpoint right there. Close it off there and join it all up. Great. Now we have 1, 2, 1, 2. 2 edges matching up with other 2 edges. Here we have 4 polygons, and here we have 3. Oops. Here we have 3. And I really don't like these moments. You'll see why in just a second, but those moments suck. I really don't like them. So we will need to work with those in just a bit. But for now, just to make it match up, 1, 2, 3. Sure, let's make ourselves even more problems here by making this, or rather making this into a triangle by stitching these 2 points together. So now 3 by 3, great. Now to actually fill it up, if I select these 4 edges like that and I type in bridge, I can choose how many segments I want the bridge to have. Right now it's 1 segment, that's 2, 3 segments. That's exactly what I want. Hit OK, and now I have the correct polygon count here. And I'm just going to select these 2, for instance, points and stitch them together to there. These 2, stitch them together to there. These 2, oops, come on. There we go. These 2 to there, actually. And these 2 to there. And that's it. We have unclosed it. And you can see that it really loses its form when we do that, right? And that's because once it's closed, it kind of softens up a bit. You can crease. You can crease it like that to force it back into, you know, a pretty sharp shape. Wait, remove crease there, remove crease there. Give me a second, we're gonna make it, there we go, something like that. So you can bring it back kind of close to what it was before, but it's never gonna be, you know, as if it's a completely open form. That is fine. I'm going to, actually there is one thing that I want to do before. I've never tried it, so might as well try it during a lecture. If I select this perimeter, or any edge loop for that matter, I can type in expand, grow, expand, I think. Yeah, SubD expand edges. I can type in that and then offset small style a half, b half. So basically expand edges is a bevel and inset edge, inset all together working as one tool. I have never used it, so it's very, very strange for me as how it works, but let's just see. That's not that bad. So it just basically creates this expansion of edges for us, which I feel like is, you know, it sharpens up the geometry quite well. Okay, I just Ctrl Z and undid it, and let's see an alternative to this, which is Inset as a group, 0.1. And this is how the inset looks like. Kind of similar, isn't it? Yeah, it feels like it's quite similar. So we're gonna stick with inset. Then I'm just going to, I still wanted this to behave as if it's, I still want this to behave as if it's what's the word that I'm looking for? God damn it. A hole, as if it's a hole, at least from the exterior. So I'm going to actually select this whole thing again and inset it again by 0.1, just to make this area a little bit thicker. And then I want to push in these 6 polygons inwards along the kind of flat vector of this surface, right? Along the normal vector of the surface. So to do that, I will need to rebuild the Seaplane. Seaplane, enter, 3-point Seaplane, and I just orient it bottom left, bottom right, top left, right? You can see it here. It changes the orientation of the whole world for us, so that we can then select these geometries like that, and either move them in like so, right? Or we can extrude them. Again, selecting this and using extrude, you know, so now I'm extruding outwards, but you can, just to show it, but you can of course extrude it inwards as well, or extrude it outwards and then move it inwards, up to you. Like that. Then maybe select this, scale it down a bit, something like that. Yeah. Nothing more. We're still thinking about this as a sculptural piece, right? So it's not necessarily architecture at this stage. It's still a conceptual sculpture, so we don't really need to think about how this will behave as a glazing system. so it can be, you know, only this. That's fine. Okay, so we have that. Once your, oh, by the way, if your Seaplane doesn't work, then make sure to, sorry, if your gumball doesn't align with the Seaplane, make sure to right click on the gumball icon and here to choose align to Seaplane, and then it's gonna work. Okay, then to reset it, you type in Seaplane, W short for world, T short for top, enter. So Seaplane, enter, world, enter, top, enter. And you have yourselves a window. Guess what I'm gonna do with these, with the rest of the windows? Same thing. So I will most definitely speed up this process because it's just a repetition of what I've done right here. Here we go. We have ourselves, oh, I forgot to reset the Seaplane. Seaplane world top. There we go. So we have ourselves a bunch of opening things, windows. Not sure how to call these, but you know, they're here. From now on, everything that we're gonna do is detailing, and also we're gonna work on the landscape, right? So I want to finish up with the form, and then we will move on to the landscape portion of it. So there are a few things that I want to kind of address. First one is, how do I even phrase it? The sharpness of things, right? So for instance, these details that we have, these guys, they really smooth out, so we lose that kind of a nice little information, you know, of these junctions. Not junctions, but protruding volumes within the junctions, if that makes sense. So how do you bring that back? Well, that's a similar approach or technique as what we used here, and that is called inset, right? So we can use an inset tool to do it like that, right? And suddenly this gets sharpened up. So that's one way. Another way of doing it is with a bevel tool. So if I map out, or if I select the boundary, the edge loop boundary, which I want to sharpen, and I add a bevel to it with 0.05, let's say 5 centimeter bevel, like that, that is also going to sharpen, right? The problem with a bevel is that it really likes creating n-gons. In this case it didn't, but trust me, it does like its n-gons. But the benefit of a bevel is that you can, since you are selecting the edges and not the polygons, you have a little bit more freedom in what and how you select things, right? So it's a little bit more forgiving. So for instance here, I will add as well a bevel, oops, 0.05 just to get a very sharp edge here. And if I look at it via EMAP, that is the best way of how we can kind of analyze the curvature of the geometry. You can see that that area right there, well, let's do a true sphere. That area right there has really been sharpened up compared to the rest of the shape. And of course these areas here are also quite sharp. Let's go for something that is a little bit more user-friendly, right? So this reflection just shows how sharp it became. So you can control the sharpness with Bevel quite well. I'm gonna add it here. Just keep in mind that with Bevel 0.05, with Bevel, you really want to strategize as to what you're gonna sharpen first and next and so on, or else it's just going to become more and more of a mess, right? Bevel tends to, as I mentioned before, create n-gons that are really hard to control. So just be very mindful of that. I will probably add a bevel here on this edge, just like that, to accentuate the bending of things. And you can see that here my geometry will break. That's fine. We will figure it out. That's another thing that Bevel does. It likes to break the geometry. That's fine. We'll fix it now. So here we need a bridge, just like that. Here it says that, well, for the bevel to work, I will need to, how do you say? For a bevel to work here, I will need to create a triangle. That's fine. Will a bridge work? No, bridge will not work. So we do need to do a 3D face and just create a triangle here. Just like that. And there's gonna be another one, a small one right here. Right? So that's what I meant by bevel, like when you're using bevel, being very mindful as to how you use it and where you use it. I will add a little bit more of a beveling here, just to kind of make everything a little bit more crisp. Tab. Yeah, that seems that now this hole is a little bit less amorphous as it was before. And that is good with me. Everything else, like, I could start, you know, saying, oh, I need this edge to be sharper, right? Just bevel it. Bam, sharp edge. Easy. Right, but I kind of like the blobbiness of it, so I'm not gonna... Well, maybe that one actually I want to sharpen. I've changed my mind. Sue me. So yeah, that one I will keep pretty sharp, but everything else we keep pretty amorphous, except for this extension right here. And this one I purposely kept unchanged. Right, I didn't add a window here just yet because I want to think about this expression, because the expression as it is right now is a little bit on the boring side, I would say. So I kind of want to fix it. I'm thinking of just taking this and just extruding it. So we need to change the Seaplane again. Seaplane. 3-point here, here, here. Just grabbing a Seaplane right that, like that, and just extruding it out like that to this length, something like this. And as you can see, the the proportion is not there, right? It's doesn't look that great. Doesn't look that great. That is fine. we will fix how it looks. Let's just first find a nice little angle. Maybe something like this, looking downwards. Or should it be looking upwards? Nah, downwards is fine. Something like that. And now we're going to play a little bit with the seaplanes and projections. So this is going to be an exercise of changing the seaplanes and projecting points onto different seaplanes. Right, so this one actually, I think it's protruding right now a little bit too much. So I'm just going to bring it back just a tiny bit to something like that. I think that's gonna be fine. All right, so now our little exercise with the seaplanes. If I change the seaplane right now to 3 point and I snap it to this surface right here, you know, to this surface, I'll align it with that surface, then I can take these points and project them. Oh, sorry, project to seaplane. And I can project them to seaplane. Well, that didn't work. Delete input objects, yes. I forgot to do that. So those points will get squished or will get projected onto the same surface or the same seaplane as this surface right here. Got it? So I need to go around this whole, like all of these sides, these two other sides, and do the same thing. Seaplane, seaplane, 3 point. And then just choose whichever you want, as long as it's, you know, within the same, come on, like that, as long as it's within the same plane, right? And then just take these and let's see if we will be able to project. Delete input objects, yes. There we go, gets projected, right? So these are on the same seaplane. I understand that it's this is not, it doesn't look clean, the end of it doesn't look clean. We will figure it out, trust me. Seaplane, 3 point, last one right here. These 3 points, pam, pam, pam. Project to seaplane, yes, great. So now it's all quite messed up, as you can probably see, right? And that is normal. That should happen because we are initially not working with the last seaplane. That is the end, the end result. That is okay with us, because I will just insert edge, I will just drag it out until somewhere here, let's say, and I'll just remove or delete the messed up parts, right? Just like that. See? And this one can be easily readjusted, but I'm thinking of keeping. We could either create one more seaplane and project it, or actually I just wanna kind of finish this off. So sure, let's just have it a little bit messed up at the end. Insert edge right there. Stitch these two together like that. Do that. Perfect. And then we can either project or we can just call it a day. There is one more way of how you can kind of do it, and maybe I should show it. I'm not sure how you can, I mean, clean this up. Yeah, let's do it. So if I were to create the grasshopper file, grasshopper, one more little script. If I have a bunch of lines and I have a surface that I want to follow, so let's create a surface. First of all, 3D plane, or just plane, not Seaplane, just plane. Oh yeah, we do need to reset the Seaplane to world top to be able to create like a normal surface. Just a rectangular surface, nothing fancy. Drag it all the way up, all the way to here. Scale it a little bit down, it's way too big. Zoom into it, move it up, move it to the side, rotate, and now let's position how we want this window to end, right? So here I'm doing it by eye. And you can do it any way you want, right? So you can be very precise about it, and then do it in measurements. In my case, it doesn't really matter. So I'm just gonna have it something like that, right? So that's one thing. That's the line. Sorry, not the line, goddammit. That's a surface. What am I saying? That's a surface. Surface, right click, set one surface. You know, this gets linked in here. We're Gucci. And then I'll just hide it for a second so that I don't accidentally select it. Then we need all of these lines, right? So I'll just draw them real quick. Line from here to here. The direction of the line matters. So you need to draw them from, all of them need to be pointing towards the surface, right? So you start, its start point is here and end point is here. If it's other way around, it would be pointing away from the surface, right? So start point here, end point here. Just like that. That line right there. That line right there. Like that. And like that. There we go. We have ourselves a bunch of lines. Select curve, CRV, for curve component, right click, set multiple curves. We have them in Grasshopper. Okay, now I want to take these curves and extend them until they meet this surface, right? So there's a way of how I can do that with extend curve, for instance, right? Wait, is there a curve to extend extension length? No, that's just the length. Just a second. Intersect physical region. Is there a ray? Mesh ray. Okay, sure. So what we want to do with these curves is we want to scale them up so that they intersect with the surface, right? So I'll just use scale component, scale, like that. Our scaling center point is going to be the start points of each curve, so that as we're scaling them, they increase in length, right? But they're locked to these starting points. So if I get curve end points like that, it gives me the start point and the end point of each curve. And if I use the start point as my center of scaling, that's gonna do exactly what I described, right? And then the factor is, well, it's like a proportional. So if the factor is set to 1, that's going to be the original size of the curve. If the factor is set to 2, that's going to be 200%. 0.5 is 50%, right? So I'm just going to create a slider between 1.00 dot dot and 5.00. Remember how to create the slider? One number, which is the minimum number of the slider, dot dot, second number. Hit enter, connect that to the factor, increase it. You can see the curves now increase, right? So now we have a surface and we have the curves, so we can find the intersection points. Intersect. Let's just find them through here, through the top. Intersect, I believe it's going to be physical surface curve. There we go. That's the intersection that we want. Surface is here, curve is here, bam, we get a bunch of points here where it's intersecting. That's all we need. We got ourselves the intersection points. So now I can just easily take it and bake it out to, doesn't matter which layer, just default layer. So I'm baking out the last node here. And then I'm just gonna group all of this. Find intersection between raise and a surface. Just like that. Hide all of it. And we have ourselves some points. So now look what happens when well, first of all, let's get rid of the curves. Cell CRV, delete, don't need them anymore. Look what happens when I take each of the corresponding control points right here and attach them to, move them, sorry, to the new point locations right here. Naturally, they all align then on the surface, right? Because it was literally us kind of projecting onto the surface with, well, this one is messed up. This one needs some love. Stitch. There we go. And now it's all hyper clean, you know, in all directions. So that is how you clean it up. I'm not sure if you need to do this at this stage. Oh, that's still a little bit messy here. Let's ignore that. That is not happening. No. So I'm not sure if you need to have it that clean at this stage. It can be a little bit messy because all we care about is just the initial aesthetic approach that we're gonna have with the project, right? But just having that as an option, I feel like is pretty nice. And then we just bridge, 1 2 1 2, bridge segments 2 like that. Come on, come on. Just let me, there we go, you and you. Stitch, yes, to here, correct. And then you and you, stitch to here. Perfect. It's a little bit crooked, but not that bad. Let's just get rid of that surface there because I will most definitely forget that it exists. So I'll just delete it right now as it is. And let's do the Inset Group 0.1 or even less for this one. This one I kind of want to keep sharper, 0.05 like that. And then 0.1 for this one, for the second one, like that. Then we need some way of how we can bring this back in, but it's at an angle. So the plane will need to follow this, this curve right here, the Seaplane, I mean. So Seaplane, 3-point, origin, there. My Seaplane is a little bit messed up, but that's fine. Move it in. scale it down, check it. And that's fine. That's fine. We have ourselves something. You know, not a building, but something. Seaplane, world top. All right, so that is, I think, it in terms of the building. I might, you know, from time to time come in and just sharpen up a bit here and a bit there, but in terms of the building, I feel like it's kind of want that corner to be sharper though. And this portion to be sharper. Sorry. We will do one more thing. If I sharpen up this one, so that's what I meant. I will be coming in from like time to time to just kind of sharpen up a few things here and there, just to make everything kind of behave a little bit better. And then this one as well. 0.05. Why the hell does this one not wanna... Instead of a rectangle, it just makes two triangles. Sure. No, I'm not gonna let you. You're gonna make a goddamn rectangle. You and you get bridged together. Oh, oops. You and you get bridged together with only one segment. Yeah, because now it's cleaner. You can see how from a sharp corner it just creates this soft transition here. I think that it's nice. Okay, but either way, we have ourselves like a direction in which we're gonna go. Same thing for the landscape, right? I will now take a break, but then I will continue on with modeling the landscape. Alrighty then, let's get this over with. So right now what we have is a form that is sitting in the landscape and is a part of the landscape, or vice versa, but there is still some adjustments to be made for the landscape itself. And I'm just now looking at this little point right here, and I don't really like it. Wait, let's see. So some students have asked me, why do I dislike triangles? Well, this is one of the reasons why, right? Everywhere where you have a triangle, the continuity of the curves just kind of messes up, right? So just keep that in mind, that it's a thing that happens. And I just wonder if we were to, let me just quickly show selected just to see if I'm not gonna mess anything up too bad. Come on, show selected. There we go. Let's select the curves, these two curves here. Okay, so the thought is, what would happen if I were to protect this border and then merge these 2 points together, right? That would get rid of the the triangle here. So let's first of all protect the border by just doing this. I select these edges, I type in insert edge to the side like that. Then we will need to work on this to make it work. Or actually, will insert edge work? Yeah, it kinda does. So insert edge actually worked out there. It still gives me 2 points here, right? You can see right here, these 2 points, when it's unsmoothed version preview thing, then they are on top of each other. When it's smoothed, they kind of get separated because of the tensions in the mesh. So I'm just going to stitch them as per usual, stitch them together. Okay, so that's kind of solved, I would say. So now we can do what we were aiming to do from the start. These 2 points now can be stitched together to this point. And now our transition here is a little bit better. It's still not the best. I feel like this little point, if we slide it a little bit, that might help. So I'm just gonna relax it for just a tiny bit. This is very weird that this creates a bump like that. I assume that's because of this corner. Anyway, it's hard to really get a full grasp of what's going on. You can kind of just get a feel for things when working with SubD. Either way, this is good enough for a sketch. I shouldn't have even done that, but I guess showing how you can clean things is important. For instance here, right? If I wanted to create, like right now, the way this works is you have like a horizontal plate, you have a hiccup, then a break, and then it extends, right? So it kind of rounds off to a shape like this. What if I kind of want the bottom part to dip downwards even more, but not just like not in a stupid way, right? But I want to create like a shadow line. Oh, actually, I can show you exactly what I want to do with this little shape right here. So in this case, we have this shadow line here, or shadow edge, right? And the word shadow comes from here, right? It's basically an accent that showcases the transition between one form to the other. In my case, I might want to have it in certain places, right? So I'm going to introduce it. And the way you introduce it is pretty straightforward. First, you choose where you will want it. So I'm just going to say probably these edges right here, right? Something like that. Maybe this one as well. Why not? Sure. Oops. That's a point. These edges as well. Then might as well do these, these two. Okay, so something like that, right? I will insert edge, and I will just insert edges outwards. And you can see as I try to insert them the way they are, it's not going to be happy, right? It's going to mess it all up for us. So that's one kind of problem, one issue that we need to solve, that we need to deal with. So insert edge, and I have just escaped it. Insert edge doesn't work just because of the directionality of the edges and the interaction between them. Basically, as you're trying to offset multiple three-dimensional curves that are twisting in 3 dimensions, it's just not going to give you a static solution, right? So instead, I will do something like how is that called? God damn it! In inset, not insert edge, but inset for these polygons, right? Inset group. Sure, 0.1. Why not? Just like that, and just hit escape. So we have initially created this, and by the way, I can select this whole ribbon by just clicking on one of the polygons and then double clicking on the other one. Other polygon that is on the same ribbon, right? I select the whole thing, and I can easily now, just using the gumball, extrude it down, for instance, and thus create this kind of a pillow effect here, right? But as I mentioned before, I don't want it to be happening here, right? In this area. I only want it to be happening near the building, right? So I'm going to undo that And I will fix a few things here to make it nicer, right? So I'm going to be stitching pairs of edges together. So you don't really need to, you're not going to be only stitching vertices. You can also stitch edges. And I'm not sure if you're gonna be able to stitch. Yeah, so for instance here, a triangle, right? Two edges which meet in one point. You can't stitch these two. Instead, you would need to stitch these 2 points to merge them together, right? So I'm just going around every other pair of edges and just kind of going to town at them, just stitching them like that. That's a little trick that I learned. And notice how I'm literally using like 2 or 3 come on, stitch to that point, just give me. I'm not using a lot of commands, am I? It's the same command over and over and same commands over and over and over again, right? So that is on purpose for sure, right? I want this whole thing. Why am I selecting them one by one? So SubD doesn't have a lot of commands to begin with, and you can kind of increase the speed of modeling by using different commands for different things, but the speed increase is going to be like 10%, right? Nothing extraordinary. So instead, I'm just kind of repeating simple commands so that you get the idea of modeling rather trying to memorize a million different commands. Even like said that, again, SubD tools, these are literally all of the commands that you get with SubD. Well, except a few, but there's not a lot of them to begin with. Anyway, if I want to select now this whole ribbon, this whole polygon loop, I can select the first item in the polygon loop, and I can select the last item, which is gonna be... Oh, I forgot to stitch here. So I'm just going to stitch these 2 points. My bad. Like that. Oh, not to average though. To this point. There we go. So again, if I select the first element of the loop and I select the last element of the loop with Ctrl-Shift and I double click on any element in between these two in a loop, it's going to select the whole loop for me, which is nice. And then I can extrude it downwards by minus 0.5, half a meter. Hit tab. This is how it looks like, right? Still very soft, I know, but you know, it's getting there. It's getting there. So now to make it harder, we can, for instance, I wonder how this would behave. I assume it will behave in a very, very bad way. So just like we did with the polygons just now, I'm going to do the same thing with edges. So I select this edge right here, for instance, and I select, let's say, this edge right here. And I assume that if I double click on this edge, then no, nothing happens. God damn it. Double click on that edge. Okay, sure. This one reacted for some reason. It's going to connect these two edges with a chain, right? So for these two, what if I just say bevel? And I give it a very small bevel, like 0.05, or yeah, sure, 0.05. This kind of bevel, right? It's gonna mess up this corner quite a bit, but also it's going to sharpen up the corner, right? This is how it was before. Edit, redo. This is how it is right now. Sharper, well, I feel like sharper is nicer, so we're gonna stick to it. Also, I don't like the pillow thing here happening, you know, where it's kind of tilting down. So I'm going to bevel I'm going to bevel from here until, where does it end? Until here. There we go. So from this edge to this edge, I'll just double click. Come on, just give me, no, give me, no, give me, please. Please, I'm trying to make a tutorial here. Okay, fine. Other side. There we go. No, didn't let me. Okay, sure. What about you? Sometimes, by the way, the double clicking is not your okay, fine. We use selection filter edges. I'm sick and tired of this bullshit. And we will do this with edge selection instead. That, holding shift, that, not that. I'm still struggling with selecting a freaking edge. Okay, wireframe, that. Why can't I select you? No, seriously. This is becoming a little bit weird. Now I'm able to. Well, that was a bug that I'm gonna keep, and I'm not gonna edit it out. Just for the sake of having it. Again, that's annoying. There we go. Whew. Okay, so almost all of the edges are now selected, except this, and this, and this, and I mean this, please. Okay, what about this side? Sure, that side works. Maybe I'll give it, I'll select that one and that one as well. Okay, let's see how it's going to behave if we, oh, by the way, just for my sanity's sake, I am going to named selections, and I'm going to create a new selection called front edge loop, something like that, just so that if I accidentally unselect it, I don't need to select it ever again. I have it saved, right? Because that was a struggle, and I immediately unselected it. Okay, named selections, front edge loop. There we go. Now we bevel it, and we give it a little bevel, maybe even smaller than what we had before. So 0.05 is what we had. Well, let's try with 0.05. So that's the bevel that we get. You can see it here, you know, the sharpening happening, or chamfer happening, and it goes along every, you know, along the whole thing. We hit tab, and now it's sharp. And if I go to Arctic view, and let me turn off the creases, wires, boundaries, all of it, you can see the shadow edge right here. So it's strengthening the contrast between the two objects. Yeah, so we have that. Let's go back to shaded, and let's continue working on this. That was not hard, but frustrating. Anyway, this is a pentagon, and you will have a bunch of pentagons. It's impossible to evade them, right? And this one is the most apparent one, right? This is a pentagon, and it's not like it doesn't work. It does work. It's just that it has the potential to be a mess. So stuff like this, I always am very mindful of, and try to keep an eye out for them being potentially harmful to the mesh. But either way, let's begin modeling out the surroundings. So the two things that I want to work on, and these are going to be very simplistic things, just to kind of end the tutorials, is I want to make two hills. I want to make a hill here on this area, and I want to make a hill here on this area. These two hills will be kind of visually protecting the facades from, you know, them being destroyed by trucks and cars and so on in front of the facades, right? So a little bit of kind of privacy creation is gonna happen there. So to do that, we first of all need to remember where we had our parking lot, and it feels like it's indeed here, right? This was our truck parking lot, meaning that I will want some sort of a barrier coming up along this edge, right? So to do that, maybe even like that, why not? Maybe not. Maybe let's have it like that. Sure. So something like this. To do that, I will create I'll use an insert edge method. Oh, and this is a very good example. See how all of the edges are going in one direction except one freaking edge that just decides, like this guy right here, this edge in this area, which decides that, nah, I'm gonna go in a different direction. That happens. That usually happens when you have a discontinuity here, like this discontinuity right here. In that case, you do need to work with them separately, unless that's what how I'm working with it. Maybe there is a faster way, but I'm just not familiar with it. And I'll just give it a little bit of a gap here, just like that. All right. So we have that going on. And then which one was it? It was this one, right? No, it was this one. This one goes out now, like that. And then we will need a triangle here. And yes, unfortunately, there's no way to select 2 points and just draw, I don't know, an edge between them. We will need to do this, you know, the crappy way around. 3D face, or we can do AppendFace. From edge, yes, bam. Once, enter, so that's a triangle that's being created. Then we have whatever, a quad, I guess. Do we want a quad? Yeah, we kind of want a quad. Or do we just do a pentagon? Maybe let's do a pentagon, why not? Another pentagon to take care of, to be mindful of. Okay, but either way, we get the boundary here with a few little issues. So I'll stitch these two together into a triangle, and I'll stitch these two together also into a triangle if I manage to do so. There we go. Something like that. Whew. So we have essentially done this portion. Then I'm going to select all of the edges right here that are not a part of the triangle, and I'll try to think of a way of how I can, you know, the behavior of my hill that I'm going to be creating. So the top of the hill needs to be at least a little bit flat, you know, so I will need at least two edges going in parallel, right? So I do need to insert edge here to get that going, just like that. Okay. Then I will, so like if now I just want to test it out, I can select these polygons here, this one as well, and just lift them up like that. you know, and see how that works. And that seems to be working just fine, except for, you know, I will need to sharpen it quite a bit, but it seems like it's working just fine. I might stick to having it just kind of dissolve until it reaches the end of the polygons here, but maybe not. So the way you can give it breathing room, so to say, is if you just offset it even further, right? Or sorry, use insert edge even further. Something like that, let's say, right? So now if I do the same thing, lift it up, you can see that, well, okay, this one messes up, but you can see that now we have like a little bit of a protection from the edge, from the outer edge. So it creates this kind of curvature at the end. That's something that we kind of want to happen, right? So now which areas do we lift and by how much? This is the moment where I'm gonna start lifting things. So I think this area, well, first of all, there's an initial lift for all of the areas here, right? Like that. Initial lift of, I don't know, like a meter, 1 meter, nothing fancy. And then a meter is actually too much. Sorry about that. I'm gonna do something less. 80 centimeters, 0.8. There we go. And then for the most dramatic area, you know, the area right here, I'm going to lift this up by 2 meters. Let's go for 2 meters. So 1.8. No, let's go for 2.5. So 2.5 minus 1.8 is, oh my god. Why am I struggling with this? 1.3? No. That is not it. My mind, help. 0.2 is 1, and then you add 1.5, 1.7. That is 1.7 meters. Oh my god. I will keep this one as well. Record it. This was interesting. So we make this kind of a dune shape, right? We make this dune shape, and are we happy with it? Maybe we want it to lift even more. Let's just lift this one by 0.5, something like that. Yeah, something like that will work. So we initially have created this dune shape, and now it's time to kind of clean it up. So I do like the transition here that is soft. I do enjoy the transition here that is soft, but we might need to work on it a little bit more. I'm just wondering, that's a triangle, right? That is a triangle, and that is also a triangle. Sure, why not? That is gonna be a quad. So I'm just wondering which areas to bevel, basically. Which areas do I want to be sharpened? And do I even want to sharpen the areas, or do I want to do something else with them? For instance, I could just select all of this, sorry, this as well, like that, no, like that. And I could protect its perimeter completely by choosing to Inset Group 0.1. So the perimeter gets protected, right? And I essentially what I get is a sharp transition in the bottom. That might be something that, worthwhile to do. Because then I can, if the bottom is protected, then I can kind of choose these polygons right here. And I'm purposely not choosing the last ones, the last edge here, as well as the last edge here, because I will want them to eat up the bevel. See, when I create a bevel, the last polygon becomes a triangle, or sorry, the last edge becomes a triangle. It's eating up the bevel for me. So I'm just gonna give it 0.1 as well. Like that. So we have two triangles at the end. We hit tab, we check it out. So now we have a sharp retaining wall, basically. That's fine. That's fine. That's an okay parking lot, I feel like. Let's look at it with Arctic view. That sharpness here and the parking lot's smoothness don't really talk that well, so I would need to redesign this, but maybe not for this tutorial. For now, as a first pass, that's fine. So I'm basically, as I'm modeling right now, I'm thinking about just the composition, right? I don't care if a truck will fit here. I don't care if, you know, if the turning radius is too small. I don't care about any of these things. All I care about is that the composition is correct, that the composition is good. Also, I need to stitch here, as well as insert edge, bam, and stitch here, like that. Oh, never mind, that is a correct point. It seems like it's gonna do the trick, right? Except here we do have a problem that we need to solve. Stitch to the boundary and then stitch these 2 points. That's from the inset. I don't want it to have an inset at the ends, basically. All right. So we have solved that. We have done that. Then here we had the pathway, and feels like the pathway would just be cool to have a little bit raised. Nothing more, just a little raised pathway. So I'm just gonna extrude it up by eye, just a tiny bit, like that. That was not a tiny bit. Or actually, let's keep it, why not? And I'm just gonna inset, I'm just gonna protect the pathway by using inset, right? So it just does its own thing. Also here, I kind of want to stitch, bam, just to see. That's ugly. Let's keep it that way. Let's keep it unstitched. Arctic, tab. We have ourselves like a linear member here. Great. Shade it. So notice how now I'm just kind of going through it, going through the motions without any regard to the rules, right? Because I don't need this to be functional at this stage. I know that I'm repeating myself quite a bit, but it is true. Okay, that inset group 0.1, tab it, Arctic view it. Seems fine. This wobble is weird. This wobble is very weird, so I might end up making it sharper by just introducing a small bevel to it. Now it became even weirder, so let's not do the sharpen. Let's just keep it as it is for now. Right? We have something like that, and let's just do it for the other side as well. You know, for the other parking lot as well, because here we also have, now I remember, almost forgot, here we also have the, whatchamacallit, the plaza, right? So for now, in regards to the plaza, let's do a few cosmetic adjustments, because the plaza is only going to, it's not going to have any changes in the altitude, at least I don't think so. I might change my mind, but right now I don't think it's gonna have any changes in the altitude. So for the plaza, I'm just going to select it all. So I'm just kind of looking at the my reference. I should be looking at the reference drawing, but don't have it nearby, so I'm just looking at the reference SubD geometry. And and then it goes up until here with this one. And then there's 1, 2, and a break. 1, 2, and a break, right? Yeah, okay. Gotcha. So that's our plaza thing. Like that. Sure. Oh, and this becomes just this is the parking area. Okay, so we're not actually selecting this just yet. We're only taking care of the plaza. I guess we can inset it, but let's just do named selections, because it took a while for us to select it. Plaza. There we go. Inset Group. Sure, 0.1. I keep using it everywhere, so might as well continue using it. Like that. Do we extrude it up or down? I guess it can go up. Like there is a break here. Or maybe we don't do anything with it in this area. We only move it up. Only move it up here. Here. Where else? Where else? Oh, I could do it here, but no. I'm thinking of just the points. Just these 2 points here. Just move it up by 0.5, sure. Why not? Tab it. Just a little extrusion there happening. Do we protect the perimeter on this area? Maybe we do. So like a secondary protection for the extruded, sorry, for the moved area. So let's rethink this. Maybe I need to do an extrusion instead, 0.5 upwards, or do we do downwards? No, that's downwards, so this one needs to lift up. And then we stitch things together. Maybe. Yeah, that's a little bit better. Because then it's like sticking out of the ground, right? This one is dipping in, this one is sticking out. Yeah. Feels like that's the way to go. And maybe I don't even need to, well, actually we do need to do it for this one. Because we're gonna need to have a bridge there. So we extrude this 0.5, something like that. Stitch. Kablamo. Come on, stitch. Kablamo. There we go. It's all neat and dandy. And now to just give it a little bit more, like make it hold a little bit more weight. No, that's not the way I should say it. To sharpen it. Yeah, let's go with to sharpen it. We can just add bevels. 0.05 tab. Now it's sharpened. It is going to kind of bend onto itself because of all of the mess that we have here. So I might end up creating a bevel throughout this whole area, like that. Let's see. Now that's a bit better. And I could kind of do it there, but meh. What about bevel here? Sure, why not? I don't think it matters, but might as well try it. And then we will have a bevel and a bevel on the corners right there. Always add bevels last. Always last. Never first, always last. Cool. Okay, that. Then what would happen if we take this and we extrude it down, but we stitch these two together like that, and we also stitch these 2 points together, right? We're basically sinking down only this area, and we bevel this area inwards. Oh, it's gonna break. Nice. Okay, sure, it breaks, but then what? Then we would end up having a bunch of triangles here. So this is something that always, like it used to break the SubD geometry, and it still does apparently. And that's fine, we will just append face from edge, bam, a triangle here, enter. Then we choose another face, but it doesn't let me for some reason. Escape, give me a face from edge. Okay, that's a weird behavior. Like that. Or maybe I can just make a quad that is very weird. And then a triangle. Why not? Tab. Ooh, that's a lot of tension happening. Check it with EMAP. That's not too bad. Like the transition there is not that bad, and we have a dimple there. A lot of pawns. A lot of pawns would be happening here. Okay, and I guess the last thing that I'm gonna do is I'll just solve this area, and then we will continue on with our little printing exercise. So this area is actually going to be away from the main facade of the building, because I consider this to be the main facade. So do we also want to lift it as a hill? Maybe we do. Maybe at least a little bit, right? So let's see where it is. It does the hop. Okay. So it's here. Okay. I will first protect it like that, and then I assume something like this. I will first of all protect the whole damn thing, and it's already protected here, but I guess I can just double protect it. Why not? Sure. And when I say protect, it's just literally making sure that the edges are not being displaced too much. right? So inset does that, beveling does that, expand edges command does that. There's a lot of ways of how you can protect your edges. As a group, 0.1, perfect. We have it now protected, and then we choose an edge loop, which we will lift up. So maybe something like that. Actually, let's eat up this area here. So something like that. Insert edge. Let's see where it's making a doo-doo. A lot of places actually. Okay, sure. Let's do it one by one then. Insert edge. Where? Right here? I guess right here. Sure. Insert edge, like that. All of these will insert properly. Will insert properly, I said. There we go. Like that. This actually needs to go here, stitch. Just so that I don't forget later down the line. Come on. Insert. So annoying. There we go. Insert edge. This one, enter. Somewhere here. Somewhere here. I will stitch those in just a second. Oh yeah, and now it's just trying to select the whole damn loop for me. No, that's not something that I want. So only these two. Insert edge. There we go. Okay, great. Once we're done with this, it should be faster. So delete that. AppendFace. This is the SubD, or actually let's delete all of the unnecessary ones for now. That. Also that and that. Okay. AppendFace. This is the SubD that we append to, and we do need to create those triangles here. That, and that. And then we can either, oh my god, what the hell? Okay, that was weird. Then we can choose to either create a pentagon or a triangle and a quad. So in this case, I'm gonna go with pentagons and just see if that's if that's gonna be a problem or not. Okay. So we have this done. And the process is gonna be very oh yeah, stitch. The process is gonna be very similar to what we did on the other side. Okay. Insert edge. Well, or maybe expand. Let's just see if that's gonna work. Expand. SubD expand edges. Yeah, seems like it's gonna work. Offset small. Sure. Why not? Why not? And then let's just extrude it up. Like that. Because here I want it to be a little bit different characteristic from what we had on the other side, just to be able to show you guys what's the difference. So this gets merged to this. Not just that, there's gonna be a lot of merging going on. Let me just think for a second. Sorry. Do we first stitch these? We can first stitch these together. Like that. Okay, so now it's softening out a little bit, right? And I can make it softer or less soft by just moving these edges, by just sliding these edges along the perimeter, right? So you can see that now this area is smoother, right? As opposed to other areas. I can also just select the borders where I don't want it to be that intense. And I can just move the borders down. That's what I'm gonna do. Something like that. Just move it down. Just to something like this. Right? Just a small border. And here it's, you know, there's a lot of complaining going on. That's fine. We will fix the ends in just a moment. So that's fine. Then we have a pretty large border here, and then it will need to dip down. And in this area here, maybe it's not even dipping down, maybe it's just literally being, you know, it goes to 0, like that. Okay. So now is the time to move things, move vertices around, right? To soften the whole, oops, to soften the whole damn appearance of the retaining wall, not retaining wall, visual partitioning wall thing. So you can see that I'm very, very gentle with it. I mean, it's a sketch, isn't it? Right? So it's a concept sketch, so we don't care that much. Like that. That seems to be fine. And we have ourselves like a secondary retention area, like a, is the word retention? Not retention, like a barrier, visual barrier area, right? So now let's fix this up, because I can see like there's a lot of issues with this. So first issue is, like, we can probably stitch these two together into one point so that it's less of a headache for us later down the line. No, that's a bad idea. Or is it? Maybe it's not. So I'm sorry. Stitch. That's design for you, right? We think about things as we do them. Okay, there's like one SubD edge and 2 vertices here, so let me just move this away. Yeah, there they are, and stitch them together. How does this look like now? Much cleaner. Much cleaner, except for here. This needs to become a triangle, unfortunately. But now this is better. The transition is better. And then for this one, we kind of need to do the same thing, right? So I'm just gonna, this goes here, stitch. These two become one, stitch. Insert edge. We insert the edge to whatever, to here. Select the 2 points, here and here. Stitch. And we, oh, that's an ugly one. So let's actually stitch it to here rather than there. There's too many things connecting to that, so that junction is already busy. Okay, so we have something like this done. Like, this is very sharp though, So let's move some vertices around to make it less sharp. Like that. I'm not even sliding them, I'm just kind of positioning them in a plan so that's a little bit softer. Something like that. Yeah, sure. Still very sharp. But maybe if we just protect it a bit more, then it's gonna be better. So one last thing that I'm gonna attempt to do is select the whole border here. This border right here. Right? I'm selecting it. I'm using insert edge. And I'm just gonna insert a quick little edge somewhere here, or actually let's do one here real quick. Select the same border and insert one more here. So I'm protecting this edge from two sides, right? And then we hide our war crimes by turning off the gumball and stitching the ends just like that. Is that better? Yeah, that's sharp as. It's sharp. Let's change this to Arctic. Oh, that shading was nice for a second there. Yeah, we have the wavy boy here happening. It is becoming something that we drew, which makes me happy. Okay, where were we? This, no. Where does it go? It goes until here. Right? So it gets stitched to that. That's fine. That's fine, we can have it like that. So I guess one last thing is just sharpening the things. You know this by now, Bevel. 0.05. Tab. Sharp boy. Good. Cleaned up sharp boy. This one, same approach. 0.05. Also sharp boy. Bam, 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 bam. Then this is sharp enough, honestly. I'm not gonna mess around with it too much because this seems good. That seems fine. So we have one pretty soft, pretty big transition, and the other one is pretty sharp, right? And you can see that the sharpness is controlled by how close edges are together as opposed to here, right? And how many edges you have. Keep that in mind. That's important to remember. Let's increase the height of this and then move on to our last step. That is going to be preparing these both geometries to be 3D printed. Right? So we have that. Actually, I kind of want to lift up this area as well. So I'm gonna do that. Like that, turn on the gumball. It goes up by 0.2, let's say. Did it do anything? Did I mess up? 0.2? Hello? It's not extruding? What's going on? Move? Move works, extrusion didn't. Well, that was awkward. By the way, if you unselect, you can always go to select, and this little arrow will select the previous selection, and it doesn't work. Of course, every time I show a tutorial, that's my life. Okay, let's do this like that. So why does the extrusion not work? Hell? You can be extruded. What about you? You also can be extruded. But if I select 3 of you, 4 of you, then you can't, but now you can. Okay, seems like my Rhino is bugging out a little bit. No, wait, that was a movement, not an extrusion. Strange. This was an extrusion, so that works. And that works. Oh my god, I'm gonna scream. And this also works. What? Okay, anyway. We're extruding this. We're stitching it. You know the drill. Where is it? These 2 points, they get stitched. These 2 points, they get stitched. It's a little bit difficult for me to show you, but the idea is to create a bunch of ramps, right? So I'm just kind of stitching things as I see fit. That's actually 1 point. That wasn't 2 points, even though it showed like 2 points. Stitch to here, tab, shaded. Yeah, that's 2 extra ramps, which we will bevel a bit just to sharpen them up. So that gets beveled, that gets beveled. I said that gets beveled. Come on, just get beveled. There we go. And that will also get beveled. Sharpness. You know, stuff sticking out from the ground. That's the whole spiel of this form. All right, and now for my last trick, this is just gonna be a simple extrusion, nothing more than that. I just really hope that it's gonna select properly. No, come on. Yeah. Okay. That's good. That's good. Let's do name selections just because I'm scared. There we go. And just extrude it up, right? 0.2. Now extrude works like a charm. And protect it again. Insert edge. No. Okay, name selections. Where's my I'm scared one? Insert edge. I keep saying insert edge, but it's actually inset. Group 0.1. Tab. Artistic, Arctic. Yeah, that's fine. That's fine. We're gonna work with this. This seems to be a-okay. All right, so there are still a few problems with the geometry that I would like to fix, but I feel like it's redundant information at this point. I'm not showing you anything new. I'm just repeating the same thing over and over again. So let's move on, right? To 3D print an object, you need it to be a mesh, right? This is SubD geometry. I'm gonna show you a dirty way of how to do it, quick and dirty, as well as long and hard way of how to doing it, but it's a clean one, right? So a quick and dirty way is, let me just make a copy of this. Select the SubD and type in ToNurbs, enter. Delete input objects, yes. Just make sure that you have a copy, you have copied it, right? And hit enter, right? Now this is Nurbs geometry. You can see all of the surfaces here, right? So these are surfaces. This has become Nurbs. Which means that with Nurbs geometry, we can do some extra stuff, right? Two things about 3D printing. One thing, it needs to be enclosed, right? So the shape cannot have open. Why is there a hole there? Hello? Oh, that's not a hole, that's self-intersection, isn't it? Yeah, that's fine. It's just me not knowing how to model properly. Anyway, the print, the object, can't have any holes. It needs to be a volume, right? So example. Where's my, let's just do a mesh tools thing. This is 3D printable, right? Because it has a volume and it doesn't have any openings. This is not 3D printable because it has a hole. Easy? Easy. Well, not that easy. You'll see. There are some instances where a hole is 0 millimeters wide, right? And then we will need to take care of it. But that's kind of gonna come in later. So this shape needs a bottom, right? Like a bottom box for it to work. The way we work with it is as if we work with a landscape, right? With our Nurbs landscape. Duplicate border to get the outer, we get the outer border. We, holding down the Alt key, we move it down ever so slightly. I'm just gonna move it down until it engulfs this dip here. Something like that. Yeah, something like that will do the trick. And I just use planar surface. Planar surface doesn't work, of course, because this is not, the copied curve is not planar. So I need to scale it to 0 height. Scale it along the Z direction to factor of 0, sorry. Enter. Now it's flat. And now I can use planar surface, right? So now we have the top and we have the bottom. And in between them, guess what we will have? A loft, right? So we just do a loft. You select the one curve, the other curve, you loft between them. We join everything up. We have one closed poly surface. If in your case it says one open poly surface, then you would need to select the, let me force it into an open poly surface. Delete, right? So if in your case it is an open poly surface, you will need to select it, duplicate border. So it's going to duplicate all of the borders around holes in your surface, and then you do zoom selected, and it's going to show you exactly where you have a problem, right? And then you will need to figure out how to patch it, how to clean it up. In this case, it would be either sweep between 2 rails or edge from 4, surface from 4 edges, multiple ways of how to do it. But either way, mine is clean, of course. Of course. Now, we need to cut away all of the unnecessary crap so that we don't print, just flat pieces of land, because our printer is pretty small. So I'm just going to maybe make another copy, just in case. I'm gonna make another copy, and I'm just going to, in top view, I'm just going to make a box. Whatever. Box, right? 3-dimensional box that I made in top view, and I'm just going to position that box and scale it so that it cuts away everything that I don't want to show, right? Anything that I don't want to work with. So maybe something like that we don't really need. Maybe here I'll cut away this area. We won't need that. Actually, now when I think about it, I will trim away this portion as well. Like that, and then for the back, maybe something like this. So I have like a few boxes here, right? Then in perspective, I will take these boxes and drag them up until they completely intersect with my shape. Because the next thing that I'm gonna do is Boolean difference. And also this one needs to be closer. There we go. Yeah, that's better. Right? So we do Boolean difference. Select the poly surface, enter, select one of the boxes, enter, and then wait. It gets cut away. Again, select. I do Boolean difference with one box at a time, by the way, because it's goddamn heavy. Like the procedure here is pretty damn heavy. But by the end of it, I do have this form right here that I can continue working with. Right? So this is the form that is going to be 3D printed. At this stage, by the way, if you modeled all of this with Nurbs geometry, you know, it's this and this is virtually the same, right? So you would be kind of continuing and cutting it apart with boxes, you know, as I'm doing right now. So at this point, the SubD workflow and the Nurbs workflow just merges together. It's the same procedure. That's why I'm not showing it with Nurbs. Okay, so we have ourselves a shape, right? Now we want the shape to be a mesh. So I'm just going to copy it one more time, and I'll just make it into a mesh by typing in mesh. Enter. It's gonna ask me how many polygons do I want. Usually I go for, you know, middle. Well, honestly, usually I go for detailed controls. And here I specify the maximum distance from edge to surface in, is this in meters, or I think it's in your units, right? So how accurate you want the mesh to be rebuilt. But honestly, for 3D printing purposes, since it's gonna be so small, I just go for the middle. Hit OK, and then I wait, and then it becomes a mesh. Hurrah! This is the mesh, this is the poly surface, so I don't need that. So the difference between a poly surface and a mesh is that this is all created out of, you know, triangles and quads and so on, and the density, you know, is questionable. It could be a little bit less density, but it's better to have more than less. But if I were to look at it with EMAP, well, okay, sure, it's showing me the goddamn edges. Okay, let's go for Arctic. You know, Arctic view, mesh, and the Nurbs. They look kind of the same, so it's fine. When you have the mesh done, I strongly suggest just exporting it as a, let's go for desktop, here, exporting it as a separate Rhino file. My first 3D print. My first 3D print, save. You know, it gets exported, and just open it up as a new, you know, as a new file, so that you don't have any trash in your Rhino file anymore. Where is it? There it is. Open. There we go. And from here on out, you are working with this as if it's a 3D print, right? Not as if it's a one-to-one scale architectural sculpture. So first thing is to move it, bounding box, is to move it to 0, 0, 0. To do that, I create a bounding box around it. I move from this point, and I just type in 0 and hit enter. And then zoom, select Z, S, hit enter. It just moves the whole object to 0, 0, 0 coordinates. That's the first thing. The second thing is options, or you can just write units. That's fine as well. We want it to be in millimeters now, units. Instead of meters, we change this to millimeters, hit OK. It's gonna ask you, would you like to scale it up or scale it down? We don't care, so I'm just gonna say no. Right, because we are gonna have our own little scale now. So now our geometry is in millimeters and it's close to or next to 0, 0, 0 coordinate. Then I will create a bounding box again because I need to choose the correct scale for it. And for this exercise, for you know, as your first 3D prints of Samtid course, you will be using 10 by 10 centimeter kind of boundary, right? Because we don't want your first prints to take too long, honestly. So I'm just going to scale this bounding box together with the mesh inside of it. I'm going to scale and I'm going to say from this click to this point, I want it to be 100 millimeters. We're pretty close. Hit delete. And that is your, you know, building architectural concept sculpture model thing and fit it into 100 millimeter box. I'm just thinking if I'm missing anything. I don't think I am. Okay, so now next up we will be exporting this for 3D printing. So I will select this and type in export, right? And then the way you export it is through a format that's called STL, stereolithography. STL is basically the most bare bone mesh format that you can possibly have, right? So it doesn't compress anything, it doesn't transfer any texture information, it doesn't transfer anything. Sorry about that, yet another phone call. So with STL, you do get the most bare bone mesh out there, and that will make the file size quite big because it's uncompressed, but I guess we're fine with it. So I just choose file type STL and I just type in, you know, whatever name I want. Honestly, to make everything clear, you should write your either initials or your name, just so that on the SD card we will know, you know, whose model it is that we're actually printing, right? So it's gonna be easier for us. So I'm just gonna say Gediminas first model. Let's hit like that. Hit save. It's gonna show you how much it's gonna take up. You want to save it as a binary, and where it says export open objects, well, honestly, you untick that because if it's an open object, you don't want to save it, right? Because it's not gonna print anyway. So binary 8.9, yeah, and hit OK. File successfully saved. Great. We have ourselves a 3D printable file. Not to say that it's going to be immediately, you know, you just throw it at a 3D printer and it's gonna do its thing. No, you need to slice it up. And the way you slice it up is with a separate program that's called, well, there's many of them. All of them are called slicers, like G-code slicers or whatever. The one that we are using in the school is called Cura, Ultimaker Cura. There's like the Prusa slicer as well, and there's other ones. But the one that we are using is Ultimaker Cura. So you can just find it if you in the start menus, if you type in Cura, you'll get it. The first time it opens up, it's gonna ask you for what kind of 3D printer you're gonna use. So let me remember this. How do I show this to you? You're probably gonna see after you agree to a bunch of, stuff, you're probably going to see this kind of a drop-down box where it asks you to add a networked printer. You don't care about networked printers. We use the manual ones. So add a non-networked printer. And here in this list, you go to custom. You don't go to custom, I lied. You keep scrolling down this list until you'll find Vanho. Starts with a W. Vanho. Vanho 3D printer. Right? And here it's Vanho Duplicator i3. That's the 3D printer that we have. Right? We will have more, and I'm going to kind of show you later which ones you need to install. But for now, just for first prints, we're going to use this one. You can change its name if you want to. I'm going to actually change this name to tutorial. Add it. And it just gets created, right? So that is the Vanho Duplicator i3 tutorial printer. So a few things about Cura, the way it works. So it slices your model in pieces, right? In layers, right? And then the printer will print every layer separately. I'll talk more about this on Friday on our little session, but that's how it works. So for now, just to give you an idea of the settings, right? So that we don't need to kind of do this too many times later with each student individually. You just go in and you drag and drop in. Where is it? Just a second. There it is. Gedmina's first model. You drag and drop in the STL file, and it just gets placed, in your printer. And it's not gonna be the biggest one, but it's, it's and it's nice. And you just slice it, right? Just immediately press the slide. Oh, you can't see it, goddammit. Let's do it maybe here. Sure. So that there was a slice button, and I just clicked on the slice button, and now it's done. And it says it's gonna take 3 hours, right? So you can click on preview, where it's going to show you every layer that is gonna be printed. And it's gonna show you, basically how it's gonna look like, right? So this is for a first try, it's a good enough resolution, right? So once you've done that, you can save this to disk and have the G-code that way. I'll show this in just a few seconds. There are things to change, right? So in the top you have prepare, preview, monitor. Monitor only works when you are directly connected to the printer. We are not. So it's only prepare and preview. On here, on this area, you have your settings, your print settings. And you will probably see this. You will probably see something closer to this, right? Rather than the custom settings. You actually want the custom settings, unfortunately, right? So let's go to custom settings, and here I'm just going to show you. I'm just going to really quickly go through the settings just to show you the what I use, right? And you can use something different later down the line. So for layer height, I tend to use 0.12 millimeters for models this big. Initial layer height 0.3. If you don't see initial layer height, for instance, or any of the options, you can click on this icon right here, either under quality, either under walls, doesn't matter. You click on this icon right here, which will open up all of the hidden options for you, and you can type in initial layer, what? Layer? Oh, it cares if you're in caps lock or not. Initial layer height, right? So you just tick mark it and then the option will pop up because some of the options are hidden. So layer height is 0.12, initial layer height 0.3, wall thickness 0.8, that's great. Wall line count either 2 or 3. 2 for pretty parts, 3 for mechanical parts. Horizontal expansion, we don't care about that. Top and bottom thickness, that is fine. Top layers, we can reduce this to something closer to 4. Bottom layers, definitely reduce this to something like 4. Grid density, you don't need the inside infill to be that dense, so it's like 10. And instead of grid, I really like using gyroid these days. Just feels like it's a nice little infill pattern. I'll show you what gyroid does in just a second. And then the most important, two most important things is the material and the print speed. So for the material that we're gonna have will require you to print with 205 degrees Celsius, and initial layer temperature will need to be like 215 degrees Celsius with build plate temperature at 60 and flow at 100%. The print speed, I will bump this down to 45 millimeters per second. Well, we can do like 50. But initial layer speed, this one I really wanna do like 20 millimeters per second, even maybe 15. Just to make sure that it sticks quite well. And Z-hop speed, 10 millimeters per second, that's fine. Retraction settings, let's not worry about those. Cooling, fan speed 100%. Sure, that's fine. Support. So for instance, like these red areas are where it suggests that you, well, if you're gonna print it layer by layer, it's gonna just print on top of the air, on top of nothing. So it will ask you to generate supports for this. So I'm gonna tick mark this, but for support overhang angle, I'm gonna give it a little bit of a braver value, which is gonna be like 66 degrees, let's say. And yeah, supports are placed everywhere. Let's slice it again. Let's preview it. And now you can see that it's going to place this poop here, which is the supports. And let's see if there are any... Yeah, for instance, here as well, it's going to place some supports that you will later need to break away, right? Breaking them away is not going to be that hard, but it's something that you will need to do. Okay, then for build plate adhesion, for stuff that is very small, that you want to increase the surface area of its sticking to the build plate, you use brim, and that's the blue lines right here, the cyan lines right here. But in our case, we will use skirt instead of brim, and it's just going to give us a perimeter around this, just so that it's just because our first layer is pretty wide, so it's gonna stick quite well either way. And that's it. Those are the settings. If you want to actually check the how each layer is gonna look like, you can do it with a slider on the right hand side. Oh, by the way, that's the gyroid infill that I was talking about. Oops. There we go. Kind of looks nice. This is just so that you don't print in just so that you don't print in a complete solid, you know, a completely solid object. It's gonna be 12 grams of filament. Remember we talked about the price. 1 kilogram is 300 crowns, which is around 30 euros. So if we do how do we do this? 12 divided by 1,000 grams multiplied by 300 crowns. That's this model is gonna cost you 3.6 crowns. So that's you know, or 36 euro cents. That is kind of a price comparison that I want to give you when you ask me, you know, how expensive is it to 3D print things. And it is going to take 2 hours now, not 3 hours as it was before. So we've cut away quite a few hours from there. We save this, save to disk as a G code, right? We hit save, it gets saved, and that file, that G code file that gets saved, will be put into an SD card, will be placed into the printer, and then we will print this out. We will be done. Okay, that is it. Oh boy. Now it's time for you to start designing. Or not start, but finish designing so that we can print things. I'm really excited to see what you're gonna come up with. That's it for these 3 days of tutorials, or the workflow tutorial. I'll see ya when I see ya. Bye.